Okay, so on this video, we're going to talk about systems of equations with 3 variables instead of 2 variables, but it's done similarly. Matter of fact, one of the goals in this is to try to get to where we have 2 equations, 2 unknowns, because we do know how to solve that. So the steps are pick which 2 variables that you're going to solve for first, and then use combinations of the equation to eliminate to create the 2 equations with the same 2 variables. And then solve a new system of 2 equations with 2 variables. After we've got the 2 equation or the 2 variable values, we can substitute that in to a different equation to find the 3rd variable. Well, this is great, but example 1, do you guys see in example 1 we already have 2 equations with the same 2 variables? This is very rare, but we are going to be able to look at the system of these 2 equations first. So we take x plus 3y equals -4 and 3x plus 4y. And then we are going to use elimination to solve just the system, and I'm going to put a little box around it. So if I wanted to use elimination, I would multiply this one by -3, and that would get me -3x minus 9y equals 12. And when I add those together, I'll eliminate x, and I'll get -5y equals 15. Divide by -5, and I get y equals -3. Well, that's great. I do have the y now. That's my second value. And I'm going to substitute that back into one of my equations. And I'm going to choose x plus 3y, and I'm going to put my y value in. Equals -4. So x minus 9 equals -4. After adding 9, my x is 5. Ooh, that's squishy town. So now I have x and y. So I only have one more equation, and that equation is the only equation with z in it. So I take 2 times my y minus 3z is equal to 0, putting my y in there. And then I'm going to solve it. So -6 minus 3z equals 0. Adding 6 to both sides. -3z is equal to 6. Divide by -3. Z is equal to -2. Okay, and then there's my ordered triple. That's my solution. So like I said, this first example was pretty nice because we already had 2 equations that only had 2 variables and they were the same variable. So if we look at example 2, you can see that we do have one equation with only 2 variables. So we can go ahead and put that in our box. X equals -3y. So you can see how this equation doesn't have a z. So we are going to try to eliminate the z using equations A and B. So if I was going to do that, you can see that I would have A plus 2 times the B. So my A is 3x plus y minus 2z equals 22. And 2 times my b, that means 2 here, 2 here, 2 here, and 2 here. So that's 2x plus 10y plus 2z is equal to 8. So when we add that, we can see that the z's will eliminate, and we'll have 5x plus 11y equals 30. And we're going to go ahead and put that in our box and use substitution or elimination to solve for x and y before we come out of the box, knowing that we still need an ordered triple. Okay, so we see that we already have y alone, so we can use substitution. Everywhere we see an x, we can put a -3y. So 5 times -3y plus 11y equals 30. And so -15y plus 11y equals 30. And so negative 4y equals 30. So when we divide by negative 4, we're going to get y is equal to, the simplest form is going to be 15 over 2. Now, I know that that's not the prettiest number in the world, but it's still okay. We're still not leaving here because we still need to find x. So we go up to x is equal to negative 3 times y, and we put our y in. And we're going to get that x is equal to a positive 45 over 2. Now we have our x and our y, and we're going to go find our z by using either a or b. And I'm going to go ahead and use b. And so we have x plus 5 times y plus z equals 4. So I'm going to go ahead and I'm going to put 45 over 2 in for the x and negative 15 over 2 in for the y. Now, I'm not a fan of fractions, so I'm going to multiply all of these by 2. So I will have 45 plus a negative 75 plus 2z is equal to 8. So negative 30 plus 2z is equal to 8. So after I add 30 to both sides, I will only have to divide by 2 to get my z equals 19. Going back up to the ordered triple to put the solution. Whew. For the next problem, we are going to see that there's no equation that has just two variables. So we are going to try to figure out by looking at the x coefficients, the y coefficients, and the z coefficients to see what we can eliminate, what we could use to eliminate the easiest. When I look at the z, I see that these two eliminate, but I know that if I use these two, it's going to be a little bit of a multiplication problem, but you can still do that. What I'm going to do is I'm going to pick one of these because they have just a negative one, which is going to be fairly easy to turn into something else. So I'm going to go ahead and I'm going to eliminate x. So I'm going to choose x to eliminate. And then I have three combos. I can use AB, BC, or AC. Well, I know I'm going to have to use B because it's going to make my life easier. So I'm going to use AB and BC. All right. So for my first situation of A plus B, I see that I'm going to have to multiply 2 times all the values in B in order to eliminate the x. So my A is 2x plus 3y minus 2z equals 1. And my B, if I multiply it by 2, will be negative 2x, negative 2y, plus 4z is equal to 10. So that will eliminate my x, which is nice because that's what I chose to eliminate. And I will get y plus 2z is equal to 11. Okay, so there's one equation because I need two equations with the same two variables. So let's go ahead and put that in a box. So right now we have y plus 2z equals 11. Okay, so this one came from there. Now we're going to do b plus c, but we are going to take b, and instead of multiplying it by 2, let me pick up the eraser. We are going to actually multiply this by 3, because if I add b and c, in order to get it to eliminate the variable x, we would need a negative 3x. So minus 3y plus 6z equals 15. And then we have our original, which is 3x plus 2y minus 3z equals negative 6. Okay, so now we can see that we eliminated the x again, which is what we needed to do. And we get negative y plus 3z is equal to 9. Okay, so we're going to go ahead and put that in here. plus 3z is equal to 9. Okay, so now we're going to stay inside this box until we have solved this. So what we're going to do is we add these together, and you can see we eliminate the y, and we get 5z is equal to 20. So when we divide by 5, z is equal to 4. Well, that's great, because remember, I still need an ordered triple. So I just got one of them, which is z, so that is 4. But I'm not leaving here until I get the other variable that's in here, and the other variable is y. So I know that y plus 2 times z equals 11. So we're going to go ahead and put the 4 in, and we'll solve. So this is y plus 8 equals 11. We subtract 8, and we get y equals 3. Okay, so y equals 3. So now what's left is just to find the last variable. And you can use a, b, or c. I'm going to go ahead and use a. So this is 2 times x, which we don't have, plus 3 times y minus 2 times z equals 1. And so we'll put our 3 in for y, and we'll put our 4 in for z, and we'll go ahead and solve. So 2x plus 9 minus 8 equals 1. 2x plus 1 equals 1. When we subtract this, we're going to get 0. So the only way to have 2x equal 0 is if x is 0. And so that will complete our ordered triple. Okay, one more. This one, again, has one equation that has only 2 variables. So what we're going to do is we're going to use that in our box. And so we have x plus 2z is equal to negative 8. Well, this has no y. So we have to figure out how to eliminate the y with a and b. So what we're going to do, let me get this a lot smaller. Hold on. So what we're going to do is we are going to take a and multiply it by 3. 3 times a, and then add that to b. And that should work in our favor. And let's erase this. Okay. So 3 times a is going to be just multiplying all of these by 3. So we're going to get 6x minus 3y plus 3z equals negative 6. And then we still have our b, which is x plus 3y minus z equals 10. So this will go away, and we'll left with 7x plus 2z equals 4. And so we'll now put this over here, 7x plus 2z equals 4. Now we're not going to leave here until we have found x and z. So we're going to multiply the top equation by negative 1 to get us negative x minus 2z equals 8. And we're going to now solve this because that eliminated the z. So we have 6x equals 12. So our x is going to be 2. So our x is 2. We still need our other 2, but we're not leaving this box until we find our z. So our x is 2 plus 2 times z equals negative 8. So we'll put a 2 in here, and we'll solve. Subtract 2. 2z is equal to negative 10 divided by 2. Z is equal to negative 5. Well, this is great because now I have x and z, and all I have to do is find y. Now, obviously, I'm not going to be using c in order to do that. So I'm either going to be using a or b. I'm going to use b. So this is x plus 3y minus z equals 10. Let me move this over. And so we will take the x and put it in, and we'll take the z and put it in, and then we'll just solve. So 2 plus 3y plus 5 equals 10. 3y plus 7 equals 10. We just subtract the 7. 3y is equal to 3. Divide by 3. And finally, our y is equal to 1. And there's our last ordered triple. Okay, well, I hope this helped you guys. Take care.